In this video, I'll be demonstrating DroneWiS, automated simulation testing of small unmanned aerial system in realistic windy conditions. Our primary motivation is that current SUS simulation frameworks, such as Gazebo and AirSim, only provide simplistic and stochastic wind models that are unrealistic. Also, some developers use computational fluid dynamics tools for such high-fidelity wind simulation. However, this process is laborious and is repeated multiple times for different simulation scenarios. Specifically, high-fidelity wind simulations in SUS simulation testing involves specialized tools from different domains. In a previous paper, DroneRack Validator, we developed a tool to automate the 3D environment generation, providing developers a way to automatically generate high-fidelity environment without the need of 3D designer. With the introduction of DroneWiS, we further improved the fidelity of the original DRV platform by automating the process of high-fidelity wind flow generation. Developers will still use the original platform and provide 3D environment specification. Then the terrain is fetched and scanned using a voxel grid scanner in the DroneWiS component. Then the scanned voxel grid is sent to the OpenForm CFD tool to compute wind vectors. The wind vector is then pre-processed and fetched at simulation runtime. This automatic pipeline allows developers to only provide geo-coordinate location and conduct high-fidelity simulation in realistic 3D environment with high-fidelity wind simulation. Now, allow me to demonstrate the entire automated pipeline. First, the developer will specify the wind condition using wind type, wind direction, wind velocity, and fluctuation percentage. Then, the developer will specify where the simulation takes place. For example, we're using this location. Then the developer will specify the drone specification. For this example, we'll be using a square mission. Then developer will select which test property to monitor. For this example, we'll select collision and drift monitor. Upon finish configuring, developer will click finish. Then our engine will start scanning the specified region by first loading the entire environment, then overlaying the voxel grid. After the scanning is done, we'll start the CFD simulation. Once the CFD simulation is finished, the drone simulation will start and apply wind velocity to the drones based on the current drone location. Once the simulation is concluded, we can review the flight using the report generated. As you can see, in this simulation, there's no violation to the collision report, and the drift is within the tolerance threshold. Here is the wind vector field generated and used in the simulation.